This video is for section 8.5. It's on trapezoids. We're going to look at what's called the mid-segment of a trapezoid. The mid-segment of a trapezoid is the segment that joins the midpoints of its legs. So remember, if this is a trapezoid, the bases are the sides that are parallel, or in this case, appear to be the ones that are parallel. Notice how these ones clearly aren't parallel by appearance. So those are the legs. What you need to do is find the midpoint of each leg, which isn't difficult. You know a point is a midpoint if these two segments are congruent, and they are. If these marks weren't here, that would not be a midpoint. Likewise, this side, that point has to be a midpoint. You know it's a midpoint because of these matching marks. Now, if you connect those two midpoints of a trapezoid, then you get what's called a mid-segment. And the mid-segment does some neat things. If you notice, if you draw a mid-segment on a trapezoid, it actually ends up giving you two other trapezoids that are smaller. Theorem 8.17 tells you what we know about mid-segments of a trapezoid. It's just like the mid-segment of a triangle. The mid-segment of a trapezoid is parallel to those two sides, those bases. So that's going to create congruent angles in our trapezoids. Also, the mid-segment length is equal to 1/2 of the sum of the lengths of its bases. So it's basically the average of the bases. So if I'd give you an easy example, maybe I say this is 10, that's how long this base is, and then I say this bottom base has a length of 20. How long would the mid-segment be? It's the average of these two numbers. What number comes directly in between 10 and 20? 15 does. Remember what an average is. 10 plus 20 is 30. 30 divided by 2 gives you 15. So if it's too much to think what number comes directly in between, just add and then divide by 2. So here's an example. Let's find the length of the mid-segment, and they're telling you it's segment MN. So if the mid-segment is segment MN, then that means N is a midpoint, and it means M is a midpoint. Find the length of that mid-segment in this trapezoid. They're telling you A to B is 20, and they're telling you D to C is 16. What number comes directly in between 16 and 20? 18 does. You can probably do that in your head. If you can't, or if eventually the problem gets too difficult, you take the lengths of those bases and you add them and then divide by 2. Make sure you add first, obviously. 36 divided by 2 is 18. So that's the math that's involved if you're not doing the find the number in the middle thing. So mid-segments are a very simple concept. Sometimes you get examples like this, though. We're going to work this one through backwards. You'll see what I mean in a second. We're going to find the length of the base, segment AB. This is one of the bases. It's the longer base on this trapezoid ABCD. They're telling you distance from M to N is 9. And distance from D to C is 5. Now, something to notice here. Point N is definitely a midpoint because this segment and this segment are congruent. M is also a midpoint, same reason. These segments are congruent. So this is a mid-segment. If this wasn't a mid-segment, you wouldn't be able to do this problem. Okay, so make sure you know that first. If this base has a length of 5 and this mid-segment has a length of 9, how long is this other base? It's going to be 13. We're 4 units away here. You need to be 4 units away here. 9 needs to be in the middle. You can always check your work. 5 plus 13 divided by 2. 5 plus 13 is 18. When you divide by 2, you get 9. Best way, though, is maybe just subtract here and get 4. and then add 4 to 9.